Tonight's video is on section 2.4. It is called chain rule. The derivative of a composite function using the chain rule. So let h of x be a composite function. Again, a composite function, we learned that last year in pre-calculus, in which one function is inside of another function. To use the chain rule on this to take the derivative of h of x equals the derivative of f, or in other words, the outside function, and you just carry the inside along with you, times the derivative of the function inside. Let's proceed to go through a few examples. Y equals sine of 2x. So let the composite function, the outside function, be sine of x, and the inside function be 2 of x. So in order to take the derivative of y, I'm going to take the derivative of the outside function and carry along the step on the inside, multiply it by the derivative of the inside. And then I'm going to go ahead and rewrite that. Let's do another example. Y equals the square root of 3x squared minus x plus 1. Up until now, we would not know how to take the derivative of this. I'm going to first rewrite this. Change the square root to 1/2. And so my outside function, or my f of x, is the square root. So bring down the 1/2, leave the inside alone, and reduce that power by 1. Then I'm going to multiply it by taking the derivative of the inside next. Maybe we'll do this to make it clear, and then I will clean this up. 6x minus 1 is in the numerator, 2 is in the denominator, and so is this, and I'm going to put a square root back around it again. There is the derivative, or the slope of the tangent line, at any point. Let's do another example. Y equals x squared plus 1 quantity cubed. To take the derivative, I'm going to use the chain rule. I'm going to bring down the 3, carry the inside along, reduce the exponent by 2, multiply, now take the derivative of the inside. And then go ahead and rewrite this. Next, f of x equals 3x minus 2x squared quantity cubed. Take the derivative. Again, I'm going to do the outside function. Bring down the 3, carry the inside along. Oops, it's a 2. Reduce the 3 by 2, then take the derivative of the inside. That would be 3 minus 4x. Proceed to clean that up a little. Actually, I don't think I need to. Everything is in the numerator position. I'll just start with a new function. Do another example. Cube root of x squared minus 1 quantity squared. So maybe I'll rewrite that first. That's x squared minus 1 quantity squared, and a third root means the 1/3 power. So a power raised to a power, I can multiply those two together. Now I'm going to proceed to use the chain rule to take the derivative. So I'm going to do the outside function, bring down the 2/3, x squared minus 1. Now I'm going to decrease 2/3 by 1. That'll be negative 1/3. Multiply it by the inside, which would be 2x. We'll proceed to clean that up. That is in the numerator. This is in the denominator along with this. Let's see, minus 1. Again, I'm just going to continue doing examples. It's probably the best way for you to understand this. So I'm going to take the derivative of the g function, which is negative 7 over 2t minus 3 quantity squared. So I'm going to go ahead and I'm going to use the product rule, the quotient rule first. And then when I do the derivative of the denominator, I'm going to have to use the chain rule. So in the quotient rule, I take the derivative of the numerator, leave the denominator alone, subtract, leave the numerator alone. Now I have to take the derivative of the denominator. This is where I'm going to use the chain rule. I'm going to bring down the 2. This is 2t minus 3 to the first power times the derivative of the inside, which is 2, and that is all over 2t minus 3, and that would be squared, which would be to the 4th power. Let's go ahead and clean this up a little bit. So this all goes to 0. So what is this? This will end up being positive 7 times 2 times 2, so that would be 28. 2t minus 3 to the first power over 2t minus 3 to the 4th power. We can divide by 2t minus 3 in the numerator and denominator. So it's going to really be 28 over 2t minus 3 to the 3rd power. Another example. This one here, we'll have to use the product rule and the chain rule. So here's the product rule, and within this piece of it is the chain rule. So maybe I want to rewrite that first. So let's take the derivative. So I'm going to take the derivative of the first, leave the second alone. I might as well write it like this with the square root, plus leave the first alone, take the derivative of the second. Now I want to use it like this. So bring down the 1/2, 1 minus x squared to the negative 1/2. Now take the derivative of the inside, which is just, negative 2x. Now let's proceed to clean that up. So let's see here. This is just 2x times the square root of 1 minus x squared. What do we have going on over here? Numerator. So actually I should put a minus. Make it 2x cubed. That 2 is in the denominator, and so is that, and I'm going to put a square root around that. I can simplify it like so. And I think I'm going to go ahead and also, again, that's a minus sign, sorry for that. I think I'm going to go ahead and clean it up, and also by making a common denominator, multiplying this term by the square root of 1 minus x squared over 1 minus x squared. That'll get me 2x times 1 minus x squared, because this times this will undo the square root, minus x cubed all over the square root of 1 minus x squared. and then that will be 2x minus 2x cubed minus x cubed over the square root of 1 minus x squared, and I'm running out of room. I guess I will put the answer here in front. I have -2 and -1 of these, so that will be -3 of them. I think I'm going to also take out an x. So maybe I'll write that here. 2x minus 3x cubed. I'm going to go ahead and take out an x. And then, so that would be 2 minus 3x squared all over the square root of 1 minus x squared. Let's do another one where I have to use quotient rule. And chain rule. So the first thing I'm going to do here is again work on the outside to carry the middle along, reduce the 2 to 1, times, now I'm going to take the derivative of the inside, and the inside is where I'm going to use the quotient rule, so you'll start putting a bracket. So that is take the derivative of the numerator, copy the denominator, minus, leave the numerator, take the derivative of the denominator, all over the denominator squared. So there's a variety of things that we could do here at this point. I think I'm going to go ahead and work on this here in this numerator, because again this would be like a distributive property, and that's just going to get messy. So I just distributed here, and so a 3x and a 2x is 6x squared, negative 6x squared, negative, that'd be negative 2x, negative, that's positive 2x, all over my x squared plus 3 quantity squared. Oops, I forgot to put this. Maybe I will combine like terms here. It's a negative 3x squared plus 2x plus 9 in that numerator. I think I'm going to leave that alone, but I can go ahead and multiply those together pretty easily. When the bases are the same, what you do to their exponents is just add them. Let's see. Let's do a couple of trig examples. So to take the derivative of the outside, just carry the inside along, then take the derivative of the inside, rewrite. Done. Let's try another one. This time I'm going to put the square instead of on the x on the outside. And that's only for the 3x that's being squared. So the most outside thing is still the cosine. So negative sine, 3x quantity squared. Then the next inside thing is this piece here. So that's bring down the 2, reduce the 2 to a 1, then take the derivative of this inside, which is 3. Proceed to clean this up. 3 times 3 is 9 times 2 is 18. And I need an x, sine of 3x quantity squared. Huge difference between these two problems. I am almost done. Do yet another trig. Now what is that square? You might want to rewrite this so you keep this straight. It's the cosine that is squared. So in taking the derivative, the most outside is this square. I'm going to bring down the 2, cosine of 3x to the first power. Now go inside, the next piece is the cosine, negative sine of 3x. Go inside again, take the derivative of 3x, which is 3. Now I'll proceed to clean it up. Negative 6 cosine of 3x times sine of 3x. These can get a little tricky. Last problem. We're going to find an equation of the tangent line to the graph f. And I'm actually doing number 67. So here's my f. This is square root of 3x squared minus 2, and I want to do this at the point that lives on here, 3, 5. So at this point on here, I want to find the equation of the entire tangent line. So first I have to find the slope of the tangent line by taking the derivative. So maybe I want to rewrite that. That's what I'm going to do first, that most outside. Now get inside, and that would be 6x. I'm going to go ahead and clean that up just a little. 6x is in the numerator, 2 is in the denominator, and this is also in the denominator. 3x squared minus 2. So that would be 3x over the square root of 3x squared minus 2. Now I'm going to do it at this x value, 3. I'm going to substitute that in. There is the slope of the tangent line, but it didn't just ask for the slope of the tangent line, it asked for the entire equation. So remember, this point is on this graph, but this point is also on the tangent line. So we're going to use point slope form. Again, this is my x and this is my y. Minus 5 equals, here's the slope of the tangent line, x minus 3. So we could leave it like this, or if I want to put it in slope-intercept form, multiply that through, and add 5 to both sides. I would need to then combine those fractions. So 5 is really 25 over 5, so it's 25 and a negative 27. It's a negative 2/5, so that's in slope-intercept form. Or maybe they might give you a choice on the AP test that's in standard form, in which there are no fractions. So if I want no fractions, I would take this whole thing and multiply it by 5, and I'd put everything on one side of the equation. So 0 equals, that would be 9x. I'd bring the y over, that'd be a negative 5y minus 2. So this is in standard form. This is slope-intercept form. And of course we start out with point slope form.